This video is going to be a tutorial about customizing Wireshark for wireless frame/packet capture analysis. Being able to perform captures is an important part of being a wireless engineer. However, for new wireless engineers, it can seem a little overwhelming. It can be confusing on where and how to begin. Don't be overwhelmed. My goal here is to provide some guidance on where to start, and getting started is often the hardest part. Additionally, being able to discern anything useful from the captures can be somewhat frustrating at first. Being able to customize your capture analysis tool is invaluable in identifying and solving wireless issues. I'm going to start with configuration profiles. I've started with a default profile, and I'm going to walk through some steps of editing this profile so that it can be used for 802.11 capture analysis. Depending on the specific task you're performing, you may want to save different profiles. You may find it helpful to have profiles for troubleshooting, site surveying, roaming, security, QoS, etc. Every time you create a new profile, it starts with default settings. Settings are easy enough to import and export though, so you can build new profiles from old ones. Or if you found a profile online created by someone else and you want to use it, just import it. If you're concerned that at some point you've changed the settings on your default profile, don't be. You can copy the settings to a new profile and then delete the default profile. Once you delete the default profile, it'll be restored with all default settings. So I'm just going to go to Edit. I'm going to go Configuration Profiles. I'm going to click the plus button, and I'm going to create a new profile. Once I do that, I'm in a new profile. We'll go back in just to confirm. I'm in a new profile, but it still has all the default settings. I'm going to reference this a little later in the video. If you have a need to decrypt frames, you'll need to add the passphrase for your wireless network to Wireshark. You'll also need to be sure you capture the four-way handshake when the designated client connects to the network. Without this, you won't be able to decrypt the frames. If you're performing captures on a network with a type of WPA enterprise authentication, you won't be able to decrypt the frames. Depending on the problem you're attempting to solve, it may be necessary to create an open network or a PSK-secured network temporarily to aid in the debugging process. Before capturing and decrypting data, you want to be sure to check all organizational policies and remember to get permission in writing. So I'm going to go ahead and I'm going to go to Preferences. I'm going to click on Protocols. I'm going to scroll down to IEEE 802.11. I'm going to select next to decryption keys the Edit button. I'm going to click the plus sign. I'm going to select WPA-PWD. That's for passphrase. I'm going to select pass 1234 as the passphrase. I'm just using that as a placeholder, using 8 characters because the standard requires a minimum of 8 characters for the password. I'm going to click OK. I'm going to click OK again. And now I have the ability to decrypt frames for this capture, provided that I've collected the four-way handshake when the client connects to the network. One additional note regarding passphrases is that they are profile specific within Wireshark. Next, I'm going to touch on coloring rules. Using coloring rules to make specific frames stand out is critical. I've been using these coloring rules for some time now, and I'm not 100% certain, but I think I may have gotten them from Wi-Fi Nigel when I first started into wireless analysis. I've made some changes since then, but I think the bulk of them are still intact. Like configuration profiles, coloring rules can be imported and exported. So we're going to click View, go to Coloring Rules, click on Import. I've saved these ahead of time. I'm going to go ahead and import them. You can scroll down here and see different frame subtypes have been configured to have different colors. You can apply different rules based on frame type, subtype, element, field. And specifically, I'm going to scroll back up and you can see that I've added this one for retries. wlan.fc.retry equal to 1 is this obnoxious fluorescent green color. When we click OK, you can see that fluorescent green really stands out. I do that so that if I stumble into an issue where there are a lot of retries, rather than spending a lot of cycles digging into something else, I can go to the root cause and figure out why are there so many retries. One additional point I'd like to make is if you've somehow inadvertently deleted your coloring rules, I'm going to go ahead and clear these out. We can go ahead and copy from the system default, and then I can go ahead and re-import the ones that I imported previously, and then I'm back where I was. My next topic is going to be columns. Generally, I have a significant number of columns when I'm just doing general frame capture using my 802.11 profile. The reason is that I want a lot of information when I'm first digging into things. Then I can change profiles once I start to narrow in on something. I like to have columns for signal strength, but more importantly, I like to have a column for SNR and antenna noise. Signal strength being just part of the picture, SNR takes the noise floor into consideration. In some environments, the signal strength may appear good enough, but if the noise floor is higher than expected, it may not be. Adding columns to your Wireshark profile is simple enough. Simply right-click on the item and select Apply as Column. Most of the information I'm going to add can be found in 802.11 radio information. I'm going to begin by expanding the 802.11 radio information. At the top of the 802.11 radio information is the PHY type. I'm going to go ahead and right-click on this and apply as column, and now you can see it's been added and you can see the PHY types. 802.11ac, 802.11a, 802.11ax. These are different PHY types for the clients that are communicating on the wireless network. I'm going to touch on this again, but there are situations where you won't know what types of clients are in the environment because they haven't been properly documented. Viewing the PHY type can help you gather client capabilities. Next, I'm going to add data rate. Apply as column. Using data rate could allow you to determine devices that aren't using the proper data rates, or that there's some type of interference or signal issue causing clients to use a lower than expected data rate. If you see after I've added data rate, you can see different data rates for different clients. 650, 24, 6, 108.1, 6. These are just the data rates that these specific frames were sent at. Remember that management and control frames are going to be sent at the lowest supported rate so that all clients can hear them. Moving on, I'm going to add channel. If you see it, the message at the bottom of the screen that says the channel already exists, please ignore that. I'm still going through the process, but because I've been adding and removing columns while making this video, it's popping that message up from time to time. Depending on how you collect your captures, though, if you've done it from the AP, there may be frames for multiple radio types, 2.4, 5, and 6 gigahertz. Or you might be looking at a capture that was done using multiple wireless adapters. Seeing the channel is helpful to know if you're looking at the proper radio/channel. The capture that I'm using was done with a MacBook and was only performed on one channel. I typically don't add a column for frequency, but know that you can if you desire that the frequency is going to coincide with the channel. Next, I'm going to add signal strength. This one should be pretty self-explanatory. This is the signal strength as seen by the client. After signal strength, I'm going to add noise level. This gives the noise floor from the client's perspective. Next is signal to noise ratio. This value is the difference between the signal strength and the noise floor, and it's represented in dB. This is a better value to use to determine the client's connection. If the noise floor is higher than expected, a signal strength that appears good may actually not be. Typically, you want SNR greater than 25 dB for high-speed data and 28 to 30 dB for voice. That is the CWNP recommendation, and that information can be found in the CWAP 404 study guide. This wraps up the exploration under 802.11 radio information. Next, we're going to look at minimum and maximum client power. To do this, we need to explore the association request frame. I already have the appropriate filter ready to go. When I collected this capture, I made sure it had an association request frame in it for exploration. You want the signal strength of the access points to be similar to that of the clients that they're supporting to avoid situations where the client can hear the AP, but the AP can't hear the client. If the client capabilities aren't properly documented, you can see what the min-max power is by looking in the association request frames. Don't worry if this filter doesn't make sense just yet. I'm going to elaborate on filters shortly. This frame is where the client is sending its capabilities to the access point. We're going to drill down here into IEEE 802.11 wireless management, tag parameters, power capabilities, and I'm going to go ahead and right click and apply as column for minimum and maximum power. Collect the power levels of your clients and ensure your APs aren't configured to run at a significantly higher power level than your clients. I've touched on adding the columns that I generally find the most useful, but depending on the task you're performing, you may find other columns more useful or some of these less useful. You can add whatever columns necessary, but your profile can begin to feel a little cluttered if you add too many. That's why it can be helpful to have different profiles for specific tasks. Also note that if you right-click on any of these columns, you can select or deselect them at any time to remove them from your view. So let's go ahead and deselect signal to noise ratio, and now it's gone. We could deselect minimum transmit power and maximum transmit power, and you can see it begins to look a little less cluttered. The next topic is going to be filters. I'm going to demonstrate how to use filters and also how to save them as ready-to-use buttons. It's very helpful to have frequently used filters saved. Having the information available in columns is handy, but further filtering the frames can be even more helpful. I'm going to demonstrate an easy way to create a filter. Picking up using the association request frame we just looked at, I've noted the frame number and I'm going to navigate to it. Within this, I'm going to select 802.11 radio association request, type/subtype association request. I'm going to right click and I'm going to apply as filter selected. You can see it populates the information that we had in there previously. Next, I'm going to save this filter as an easy to access button for future use. Simply click the plus sign. I'm going to name this association request, and then I'm going to click OK. And now anytime in the future I want to filter just for association request frames, I just click on this button and it'll display just the association request frames from the capture. Note that the filter is green because it's a valid filter, but if the filter were not valid, it would show as red. I'm going to add some buttons for some of the filters I commonly use. Like columns, these can be edited to your preference. Some of these I use placeholder values that can then be edited as needed. I'm going to start off with SNR. WLAN_radio.SNR is less than 25. I'm going to click OK or Enter. I'm going to click the plus sign. We're going to go ahead and name this low SNR. As I mentioned before, an SNR of 25 dB is generally considered necessary for high-speed internet. If a significant number of clients have low SNR, you may have access points offline, a higher than normal noise floor due to some type of interference or not enough available capacity, or you could have a coverage hole. It'll definitely be worth investigating the root cause of the low SNR. This filter makes it easy to see which frames have low SNR. Even though SNR is a more helpful data point, there are times where signal strength can be useful as well. As a default, I use neg 70 as a placeholder, but the value can be adjusted up or down based on your requirements. So we're going to go in and we're going to edit this to WLAN_radio.signal_dBm is less than neg 70. Going to hit enter. Then I'm going to add it as a button. I'm going to name it low signal. I'm going to click OK. And now when you use that low signal button, you can see the only frames you see are those that have a signal strength below neg 70. I've got a couple more that I'm going to add here quickly. One being SSID, WLAN.SSID equals. I like to put SSID in as a placeholder when I save this button. We'll name it SSID. And then when you click on it, obviously there is no SSID named SSID, but you can go in and quickly edit this to what you need it to be. I'm going to edit it based off of the SSID here that I've done this capture on. And you can see it then only shows frames for the SSID that's specified in the filter. Now I'm going to do channel WLAN underscore radio dot channel equals 36. Generally, I like to save channel 36 as the placeholder. We'll name this channel, and then you can just go in and edit it to the channel that you need. This capture was performed on channel 48, so as you can see, channel 48. But there may be situations where you've collected a capture on multiple channels, or if it's done from the access point, you might have multiple different radios in there, 2.4, 5, and even 6 gigahertz. Also note that you can combine these filters together. As an example, I'm going to filter for frames with SNR less than 25 dB on the most commonly seen SSID. So if I click on low SNR and copy this, and then click on SSID, I can fill in that SSID name. And paste that in, and now I'll only see frames that are SNR less than 25 dB for the SSID specified. One last note on filters: you can always use your coloring rules as a source for filters. Here I'm going to use the retries coloring rule to add a filter and a button. So within view, we'll go to coloring rules. I'm going to click on the rule for retries. I'm going to copy that. I'm going to paste it into the filter section, paste it, I hit enter. These are all frames that are retries. I'm going to click the plus button, I'm going to name it retries, I'm going to click OK, and now I have a designated button for retries. The next topic is going to be DNS latency. While the Wi-Fi often gets blamed for all latency related issues, even if it isn't the root cause, being able to discern when Wi-Fi isn't the problem is extremely important. Looking at DNS response times can help determine when DNS is the root cause of the complaint. If there are delays in response times from DNS servers, the Wi-Fi may feel slow to the users, but ultimately the issue lies elsewhere. I've personally seen firsthand situations where slow Wi-Fi was being reported, and it ended up being DNS servers that were overutilized, causing delays in DNS responses. When looking on the wireless side, you'll only be able to monitor DNS latency times if you're able to decrypt the traffic. If you suspect DNS delay may be part of the issue, it may be best to perform captures on the wired side of the access point or on the wireless controller where the traffic is more likely to be decrypted. Since we began, I've added the passphrase for my wireless network, so the DNS frames will be viewable for this section of the demonstration. Also note, for this demonstration, I was sure to capture the four-way handshake from the designated client so I could decrypt the DNS frames and be able to view the DNS reply times and reply codes. The two items I'm going to cover within this topic are DNS response times and DNS errors. Along the way, we're going to add a column for DNS response time and filter buttons for DNS response time and DNS errors. It's generally best to expect DNS response times to be less than 120 milliseconds. DNS response times will often be significantly lower than that, but when they start to exceed 120 milliseconds, users will start to notice and may start to complain about poor resource performance, particularly with websites that require multiple resolutions from DNS. First, we'll go to the filter section. We're going to add a filter for DNS.time greater than 0.120 and DNS. This is going to filter for all DNS frames with a response time of greater than 120 milliseconds. Fortunately for this video, I have a few DNS responses that exceed 120 milliseconds. Then we're going to go down under domain name system response, under answers and time. We're going to right click. We're going to apply as a column. We now have a column named time. I'm going to right click on that column. I'm going to edit the name and I'm going to change it to DNS underscore response underscore time. I'm going to click OK. Then I'm going to click the plus button and I'm going to name it DNS underscore response underscore time. I'm going to click OK, and now I have a button for DNS response time. This will allow me to quickly go in and filter for any DNS frames that exceed 120 milliseconds. If you need to, you can adjust that time based on your baselines for your network whenever necessary. If on a production network you see many DNS responses that exceed 120 milliseconds, it's going to be worth exploring why. There are some helpful tools available for DNS testing. DNS Benchmark is one that comes to mind. You'll want to compare the results from the wired and wireless side. In many organizations, DNS servers are managed by a separate group, therefore you may have to escalate your concerns appropriately. Having data points to support your theory is always helpful. Next, I'm going to filter for DNS errors. Using this same DNS response, I'm going to go under flags and I'm going to go under the reply code. This one specifically shows no error, but I'm going to go ahead and right click on it. I'm going to apply as a filter, selected, dns.flags.rcode is equal to 0. I'm looking for things that have errors, so I'm going to change this to greater than 0. I'm going to hit enter, and you can see I've got a couple responses that have errors. This is a demonstration, so I'm not particularly concerned about these, but in a production network, they may warrant further exploration. While I'm here, I'm going to go ahead and click the plus button. I'm going to name this DNS_errors. I'm going to click OK, and now I've got a button. If I go back to where I was under DNS response times, I can click DNS errors, and you'll see I've got a couple DNS errors in here. To me, wireless analysis can be one of the most fun and rewarding aspects of being a wireless engineer, but it can easily be one of the most challenging and frustrating, especially if it's on a wireless network or feature that you personally designed and implemented. My goal here was to show how to begin customizing your Wireshark profile and provide some common elements to explore when performing wireless analysis. There are other aspects of wireless analysis that I've omitted with the purpose of keeping this video from getting too long. This shouldn't be considered a comprehensive list, but some of these topics include security analysis, quality of service, and roaming. If you've enjoyed this video and are interested in learning more about wireless analysis, I suggest checking out the CWAP certification by the CWNP organization. Some of the information here is covered in that certification track, as well as additional information.